problem number 5. I've been a little inconsistent with my colors, so I apologize for that. I'm going to try to be more cognizant of that from now on. I'm writing my proof here in orange, but we have our definition in yellow, and in purple we have just the problem itself. And we want to prove two ways that if set A is a subset of the empty set, then A itself has to be the empty set. Now we can try to prove this directly just by saying if A is a subset of the empty set, then by definition, for all x which are members of A, that x also must be a member of the empty set. As such, we can say that it's true that for every x that is an element of A, it is also found in our empty set. You can write it like that or like this. But because we know that there does not exist an x in the empty set, then there simply cannot exist an x that is an element of A. Thus, if A is a subset of the empty set, then A must be the empty set. And that's it, we're done. But basically, all we're saying here is that we know that the empty set is empty. And by definition, if A is a subset of this empty set, then every single x that is inside of A has to be inside of this empty set. And it doesn't even matter what A is, we know that in order for this definition of a subset to be true, every single item that is inside of A has to be inside of the empty set. All we're really doing is saying if A is a subset of the empty set, then that means that every single item that is in A has to be inside of the empty set. And I should probably add this all x here, sorry about that. This sentence is basically just saying for every single x that is a member of A is found in this empty set. But because we know that there's nothing inside of the empty set, then there cannot be anything inside of A. Therefore, if A is a subset of the empty set, then A must be the empty set. Very simply, A cannot have anything inside of it because the empty set does not have anything inside of it. And based on our definition of what a subset is, that's the only possible outcome. Now we can also do a proof by contradiction, right? Proof. Assume that A is not a subset of the empty set. This means that there exists some element x that is a member of A such that x is not a member of our empty set. And if there exists any element at all in A, this contradicts what it means to be an empty set. Thus, if A is a subset of the empty set, then A must be the empty set. And we're done. Again, all we're saying here is that we're assuming that A is not a subset of the empty set. And by our definition, to not be a subset of something means that there is some element inside of A that is not inside of the empty set. But if there's any element at all inside of A, then it cannot be empty. That would contradict the definition of being an empty set. Therefore, that is a proof by contradiction that if A is a subset of the empty set, then A itself must be empty.